Hello and welcome back to my channel. It's mail day again and a couple of my viewers have sent me a couple of items to repair, so why don't we take a look together? Okay, well, let's take a look at the first parcel here. This one comes from France, from my friend Dexter. Hi Dexter. I met him on the Retro Web Discord server. If you don't know the Retro Web, it's an amazing place where all the information about retro hardware is stored. So if you have a motherboard and you need to know the jumper setting or you need the BIOS, you go on theretroweb.com and it has absolutely everything. It's an amazing database, and thank you very much guys for keeping this alive, because it's very important for our vintage and old projects, because obviously this information tends to just fade away from the internet pretty quickly. So let's open this parcel and see what's inside. Ooh, look at that. It's quite a lot of stuff. So what do we have here? So this is kind of a modern video card. It's a GT630, 1GB of RAM, GDDR5, and this is the heatsink, which was just removed for shipping. I think I got this one. I think he had to get rid of this card, and I thought, you know what, it's a PCI card. I'm not sure I have like a PCI card like this, so I said, oh yeah, just stick it in the box and it might help at some point. Right, here we got something a bit more interesting for me. This is it's nothing special, it's just a Trident TVGA 8900C video card. It's an ISA video card, 16-bit, and the reason I got this card is that I currently have two ISA video cards, and one of the cards I was using, which happens to be a TVGA 8900D, by the way, it's very similar, turned out to be incredibly temperamental. I made a video many months ago, it's one of my first videos, so it's not great to watch, to be honest, but it turned out I had an issue where the computer, a 386 motherboard, was freezing on Doom only, and it turned out it was the motherboard. And I do remember testing computers using this motherboard, and they would just fail to boot randomly, and I thought it was the computer, I thought it was the motherboard, I thought it was the slots, and then it turned out, no, it's the video card, which is probably not happy. I can't figure out what's wrong, most importantly, because most of the time it just works. So it's difficult to troubleshoot, to be honest. And because I only have another one, I basically, chatting with Dexter, he said he had a spare and he sent me this one, and maybe we can give it a go, a quick test, and make sure it works. It's on, it needs a little bit of a clean. It's seen better days, let's put it that way, but well, he told me it works, so I don't see why it shouldn't work. I can see the capacitors here being replaced. I'm not sure whether they were damaged or just for the sake of recapping them, but as long as it works, I would be totally fine. It's going to be just another tool for my projects. And here we go, if I'm saying that right, Dexter, the piece de résistance, which is, if I remember right, a motherboard in quite a lot of need of attention. This motherboard has suffered a battery leak. So that's where the battery was. You can see this whole area here is green. These slots are green, which is horrible. I don't know whether this has been neutralized, has been washed. I need to check with Dexter, otherwise I'll have to clean it. That being said, yeah, I can see there is quite a lot of trace damage, unfortunately, like those very small traces. This is going to be a microscope job, and it will require quite a lot of work. Oh my gosh, this is worse than I thought. But anyways, it's one of those challenges I like. It'd be great to see this running again. Now, another thing I'm seeing on this board is this PCI connector here, which is broken. I'm not sure whether it was supposed to be broken, because that's where the video card was sitting on. I will check with Dexter, but yeah, obviously he will need another one. Well, I have forgotten to introduce you this board. So this is an MSI MS4143. It's one of the reasons I actually accepted to have this board. I don't have like good brands motherboard when it comes to socket 7, socket 3. This is socket 3, so that's for a 486. I only have like PC chips, which are not great apparently, or you know, you've seen on this channel the Amtrum, again PC chips and this kind of stuff. So it was nice to get like a decent motherboard, assuming this is a decent one. It's pretty much damaged, but you know, we'll see what we can do. This is again socket 3 with the ALI M1445 1439 socket. It's got PCI slots, which is great for 486. You can take up to 512 kilobyte of cache. I don't know whether this is already maxed out, because I see the cache sockets are already fully populated. Now, I thought I saw some damage here, like a broken component. It looks like resistor network. Oh, okay. That's coming from something else. I guess Dexter must have like a pile of motherboards, and this has fallen from another motherboard. Now, unfortunately, corrosion has reached the back of the board as well, which is not great, which means the corrosion, obviously, it's in between all the layers. And I don't know whether this is like only a dual layer or if it's like a multi-layer. I hope it's just dual layer. But anyways, you know, we'll do what we can and see if I can revive this one. It's gonna be an interesting project for the future. I'm not gonna test this board because, you know, it's not gonna work, and, you know, it needs to be cleaned and inspected first. There's really no point in testing it now. Oh, and I think I found where this resistor network is coming from. There it is. There's the larger resistor network here, and it's broken here at the end. So yeah, that would need a replacement as well. Okay, so let's keep this board for a future project. Before we move to the next parcel, I really would like to give this video card a quick test just to make sure it works. And here I have my trusty Socket 7 Soyo motherboard. It's kind of my favorite one. I think it's the one of the best I have. Probably the Shuttle is the best one, but anyways, that's the one I have at the moment. I'm just testing the setup, so I have my Trio 64V Plus PCI card just to make sure I have a picture. So let's give it a go. 3, 2, 1, go. And we do indeed have a picture, so we know the motherboard is working, everything is working. Let's switch that off, and let's swap this video card from my PCI card to this nice Trident ISA card that Dexter sent me. Actually, before I do that, I think I'll give a clean to the contacts here, because I see they're a bit on the tired side. I'll use a little bit of contact cleaner here on some cotton pad. Hopefully that's enough. Okay, well, let's give this a go. See if everything works. Not that I don't trust you, Dexter. I'm just, you know, testing. make sure everything is okay, so I know it works next time I need to use it. Okay, well, let's test this up in 3, 2, 1, go. And yeah, we do have a picture. That's great. It works. Even though it's probably difficult to show on camera, but I see some like sort of interferences. So let me try and like wiggle the VGA cable. No, it's not that. Let me try and spray some contact cleaner into the VGA connector. And no, the picture is a bit unstable. Let me see if I can show you a bit better. Right, you should be able to see that clearly, that the something with the timing, I guess, of the signal. Now, it could be the monitor, even though, I mean, it's the monitor I use all the time, and again, it was fine a moment ago. But one thing I can try is, well, first of all, run the auto adjust, because again, this is VGA. Ah, yes, it was definitely that. That's it, it's gone, it's perfectly fine, perfectly clear, perfectly stable. For a moment I thought, hey, Dexter sent me a lemon, I need to have a chat with him. But no, it was just the monitor that needed an auto adjust on VGA, which is understandable. Perfect, great, it works and it looks perfectly fine. So, merci monsieur, thank you very much for the video card, the motherboard and the other video card. Especially this video card is going to be a great tool in my tool bag. I would say let's move to the next parcel, which comes from Switzerland. This comes from Alex from Bern, if I'm saying it right, in Switzerland. Thank you very much, Alex. This is going to be an interesting project, I guess. A bit unusual for this channel. We'll see that in a second. Let's open it up and let's see what's inside. Oh wow, this is so cute. Okay, right, as you can see, this is not an old computer, this is not like some vintage stuff, it's actually a small video projector. And it's not one of those cheap stuff that you buy on eBay. It's an LG projector. It's an LED projector. We'll check the features in a second because I'm not too familiar with that, but it's incredibly compact. And I can see here it's got Bluetooth and DTS and all sound. It's based on DLP, so this must be a single DLP chip with the color wheel. Maybe I can explain a bit in a second. Now, let's spend a second on this DLP technology. What is DLP? DLP stands for Digital Light Processing, and it's a technology developed by Texas Instruments. Now, this happens to be a DLP device. It comes from a cinema projector, so it's pretty big. It's much bigger than the one you would find inside this little machine. But that's just the bigger brother. And if I'm not mistaken, I think this is a 2K chip, which is more or less full HD. So the way that DLP is manufactured is that what looks like a mirror surface is actually an array of micro mirrors. Each mirror is basically the pixel the device is trying to represent on screen. Now, being a 2K device, so we're talking about 2048 by 1080, that means that this device has on it about 2.2 million mirrors, and each one of this mirror is representing a pixel on screen. So the way it works in a cinema projector where you have 3 of these devices is that the white light coming from the light source is split into the primary colors. So we're talking about red, green and blue, because with red, green and blue you can basically create any colors that you have on the spectrum. So the light is split into red, green and blue. Each one of these colored light beam is reaching one of these devices. Each one of these devices is being electronically controlled by the electronic of the projector to represent a specific picture. So wherever you want a pixel switched on screen, the mirror is going to reflect the light, so it's going through the lens. When you don't want that pixel to be lit on screen, the mirror is going to be angled in a way so the light is being reflected inside the projector, is being dumped inside the projector. Now, these 3 colored beams coming from the devices themselves and then merged together, usually through an optical prism, and then funneled into the lens and finally focused on the screen. So, believe it or not, this is a mechanical device because all these mirrors are mechanically moving in order to reflect the light towards the screen or away from the screen. Now, this very small projector is not going to have 3 DLPs in it. DLPs are very expensive, and also this is very compact, even though this projector has the smaller brother of this. But no, this is a single DLP projector, like many home theater projectors based on DLP technology. But the technology is still the same, the device is still the same. The way it works is that between the light source and the only DLP device, you would find a color wheel. The wheel is made of sections, and each section is a red or green or blue color filter. By rotating the wheel, the white light is filtered so that the DLP device is receiving flashes of red, green and blue light. These chips are very fast and they can change the picture very quickly. So every time a set of RGB sections has rotated in front of the device will quickly change the picture for the next frame, basically, to be projected on screen through the next set of colored sections. So what you're actually seeing on screen is a sequence of very, very fast red, green and blue flashes, but they're so fast that our brain can't see the separate colors and basically will see a normal picture. Now, what really impresses me is that these are mechanical devices, and even if I showed these devices using my microscope at the maximum magnification I've got, you would barely be able to see the grid of pixel. And this is just a 2K device. Bear in mind that nowadays, most of these in cinemas, they feature a 4K device. So we're talking about 8 million pixels. Each one of the pixel is a quarter of the size of this one. It's just absolutely mind-blowing. But one of the most interesting things I found about this projector when Alex mentioned that to me is that it runs on 19 volts. So it comes with an external power supply, which is very much like Apple style. Let's have a look at the specification of this thing, because again, this is pretty interesting. I've never seen this projector myself and I'm pretty impressed. It's so cute, it's so small. So this little thing is nothing less than a full HD projector. As I said, it's DLP based. And it's got two small speakers. One is here on the left and one is here on the right. So it's even stereo. So this is decoding audio. The idea is that you plug your Blu-ray player or something to this, and you can project something on the wall or on a screen if you have it, and you get sound out of it. But most importantly, it says that this has like smart TV features, so it comes with Netflix. So I think the idea, I'm not sure if it got Wi-Fi. Well, I think so. It says Intel WiDi, wireless display, but Miracast, well, it's got Bluetooth. So I think the idea is you connect this to your home Wi-Fi, and it's like having a modern TV on a projector. It's pretty cool. It says the brightness is 1400 lumens, but it also says based on the perceived brightness equivalent to the brightness of the lamp projector. I mean, what does that mean? 1400 lumens are 1400 lumens, or they're not 1400 lumens. When it comes to brightness and contrast specification of these home projectors, it's very, very easy to find. I don't want to say random numbers, but like marketing numbers. It says the contrast ratios is 150,000 to 1. I can tell you this. No, there's no way this is 150,000 to 1 contrast ratio. It will use some kind of digital enhancement to get to that number, but I don't even think you can ever measure that kind of contrast on a projector like this. Right, so I would say let's give it a go, because I'm curious to see what happens. Okay, I got the projector plugged into the power brick, but the power brick is not powered at the moment. So let's give it power and see what happens. In 3, 2, 1, go. Okay, now I guess there's gonna be an on-off button somewhere. I mean, there is a remote. Turn it on. Ah, that's the on-off button. Well, it's dead.
He's dead, Jim. Well, that's impossible.
Well, there is a good news. Number one, it's an external power supply. So I would say the first thing that we can try is to try whether we actually have 19 volts coming out of this thing. The second good news is there is a service manual of this thing. And I took a look some time ago. It gives quite a lot of explanation on how the projector powers on, which is great because this sounds completely dead to me. But before going into that direction and before taking a look inside, I would say let's take a look at the voltage output of this thing. Right, okay, I got my multimeter here. Let's unplug the power supply and let's check what kind of voltage we are getting here. Yeah, we do have 19 volts, so it's not an easy fix like replace the power supply. So we will have to have a look at the projector itself. Okay. I did see a little spark when I connected the power supply, kind of suggesting might be something short inside. It'd be interesting to see whether the 19 volts stays on when it's plugged in. I would say let's open this up real quick. This is not a repair video, it's just, you know, I'm curious to take a quick look and see what happens with this projector. And if it's nothing extremely simple, I'll make a repair video out of it. Okay, we're kind of in luck because the power jack is on this little PCB which is detached from the main board, so I can plug the 19 volts connector here. I can actually measure it at the back of the PCB where the connector is soldered to it, so that should be an easy task. I'm really curious to see whether the 90 volts stays when I'm plugged in or whether there's a short somewhere and the power supply is basically disabling itself to avoid melting something somewhere. Let's power this up, 3, 2, 1, go, and let's take a measurement here, and let's see if we have any voltage. No, there's nothing, as you can see, hopefully you can see, the power supply is attempting to start all the time. So it's like, yeah, it's trying to start and probably there is a short somewhere. Well, as a quick test, there is a large diode here. I'm in diode mode, see what it reads. Okay, well, it's shorted on this direction and okay, it looks like I mean, it's not necessarily the diode, but there is possibly something wrong here. Let's try in resistance mode, see what it reads. We got 4.4, which is not a dead short. These leads read 0.4, so we're talking about 4 ohms. And it's in both directions. Let's check the capacitors. 4.4. Let's check some other components on the other side here. We got some like smaller capacitors here. 4.4. Everything is 4.4. Let's disconnect the rest of the projector. Okay, I'm curious to see whether the short is still there or it's gone away. Let's keep it in resistance mode. 4.7, and I'm assuming it's the other in both directions. Okay, again we got schematics, so I can try and take a look. But I'm just wondering whether one of these components have shorted. There's not much on this PCB. I mean, again, we got a couple of big capacitors, that diode, a few more capacitors there, a couple of inductors, and then there's a little IC, which I don't know what it does. Again, I haven't checked the schematics yet. I would say let me get the thermal camera and we'll do a quick look when the power supply is trying to power up. And I got my thermal camera out. The power supply is connected but it's not powered. Let's power this up and see if we can see anything. So 3, 2, 1, go. Okay, so I'm looking on the back side where the electrolytic capacitors are. There is a reflection. It's a shiny... Actually, no, it's not a reflection. What is that? Is there something at the back? Oh wow, look at that! We found the problem. Well, there you go, there's something at 80 degrees in that area, and that's where you got the capacitors. Now, the resolution of this thing is not enough. Okay, this is not clear. My thermal camera doesn't have enough resolution for this, which is kind of the first time that I find something like that. I think I will try, for the first time as well, the alcohol trick. Let's do this together. Okay, well, this is my setup. I got a light shining on the other end, so it should be easier to see which one of these components is having an issue. So let's apply power now. 3, 2, 1, go. And I'll spray some isopropyl. Now, the component which is getting hot will cause the isopropyl to evaporate faster. So let's spray now. Aha, look at that. We can actually see the power supply like trying. Super cool. Look at that. Yeah, it's the capacitor on the left hand side, C645. And now I'm looking closer actually. It looks like it's broken. Okay, let's take a look under the microscope. And would you look at that? It's cracked. There's a piece missing. It's burned underneath. There's a crack on the soldering. It's all cracked. So that's gone, and hopefully that's the one that was shorting everything. I'm just curious to see whether it's literally just this capacitor stopping the whole projector. So let's remove it. Right, okay, let's see if this is actually shorted. And it is 1.2 ohms. Amazing. So that's shorted. Let's check the rest of the circuit. And we have kilo ohms. Looks pretty good to me. Amazing. Right, everything is back together. Obviously there is a capacitor missing, but I feel it's gonna be fine. Again, it's one of two. There might be a little bit of extra ripple. It's probably for like protection. It should be fine for a quick test, and then I'll measure the voltage and I'll order a replacement. But what would be important now is that if I apply power to the power brick, we measure 19 volts on this board, even with the projector switched off. That would tell me, hopefully, that the problem is resolved. Okay, well, ready to power up in 3, 2, 1, go. It's working! Oh wow, it just powered on. Look at that. Well, that was interesting. Easy but interesting. It's the first time I'm actually repairing a shorted SMD component. There you go, we got a picture out of the projector. Fantastic. We got an LG null signal. Look at that. That's so amazing. And the replacement capacitors have arrived. These are SMD obviously, and it's case code 1206, which is defining the dimension of the component itself. So I would say let's take one out of this tape and test it to make sure it's a 10 microfarad one. And yes, we got 9 microfarad. These are not electrolytic, so I'm not sure what the tolerance is. but 9 microfarad on a 10 nominal one. We're talking about 10%, which should be okay, because again, well, it's on a power line, number one. Number two, electrolytics are 20%, so that being 10 is probably fine. So let's put it back on the PCB. Okay, it's done. Just to double check, let's make sure that this diode is not reading short or anything. We've got 0.5 volts in this direction. And we more or less see a capacitor charging and then no conductivity, so that is great. So this is done, we can put it back and finally test this projector properly. Yes, I completely appreciate that I've put this back together without testing it first. I don't know, I just feel optimistic tonight, but you know, to be fair, it's only a capacitor, we tested this before, so unless the capacitor is faulty, it should really work. Okay, projector is plugged in, let's give mains power in 3, 2, 1, go. Yay! And it's working! Well, it looks awful on camera. I guess obviously the exposure is wrong, but also I guess it's the refresh rate of this thing. Let me see if I can show you a bit better. I can assure you that it looks fine. This is very explanatory. Remember when we talked about the color wheel? I set the camera's shutter so that I can basically see the flashes, and you can see the red section coming in, the green section, and now the blue section. Obviously, you don't see this with your eyes, only through the camera. I tested the projector in my living room on a white wall, and I did some tests. I'm thoroughly impressed by this little machine. Now, obviously, a white living room is not a suitable room where to test a video projector, but I took some measurements and did some basic adjustments. On a 2.3 meter wide screen, I ended up with 14 foot lambdas of brightness with default settings, which is so impressive for such a small unit. This translates to 450 lumens, much different from the claimed output of 1400 lumens as expected, but that was read with the projector set to a color faithful preset. LG would surely use a vivid preset where brightness is maxed out, but color accuracy is not. As expected with DLP technology, the white balance ended up being pretty flat, and the gamma was also pretty good, considering I didn't touch it. The gamut was a bit off, but again impressive for the size of the unit. So here we are. Thank you Dexa for this motherboard. There's going to be a project at some point in the future, and for these ISA video card, which I'm going to use it for some projects in the future to test broken things, and for the other PCI Express video card, which I guess might be useful for something else. Thank you very much Alex for this very little but very performing video projector. I'm pretty impressed by it. I used to have a video projector myself, like a big home theater one, and I wasn't expecting this kind of performance from such a small machine. Now the motherboard and the two video cards are staying here. That's my new project, and this is a tool for my new project. The video projector is going back to Switzerland, back to Alex, and I hope it can deliver many more years of entertainment on screen. So this is it. I hope you enjoyed this video. If you did, as usual, I would appreciate if you hit the like button down below and consider subscribing to this channel if you like this kind of thing. For now, thanks for watching. I wish you a great day, and I hope to see you soon here on this channel for my next videos. Thank you very much, and goodbye. Bye bye.